So activity 4B, look back at the section. Let me read it from the presentation. So look back at the section on a greenhouse in chapter 3. So we need to get back again to chapter 3 and look about what was written in chapter 3 about a greenhouse. I will present it in a while and I will show it to you. So let's read the rest of the question. So by looking at those back at those chapter 3 greenhouse, we had 3 algorithms there. It was provided for temperature, moisture, and light control. We need to make it more efficient in this activity 4B. So the question says, consider what should happen if the device is already switched off or switched on, related with those 3 algorithms. Okay. Include extra statements to replace where the original algorithm has phrases like leave on or leave off. What should we do at that time? So we need to be careful and we need to put extra clear statements. So the statements, the sequence of statements needed for this will be similar to the following. It will look like this. So this is just general. Okay, so it starts with while system switch on. While system is switched on, input the value. Okay, if the value, we have a preset defined value that is inside the system. Okay, if that value compared with the preset value, if it is less, then the divide. If the device is off, then what to do? End the if here, and else if the device is on, then what you should do. Send the signal for switch on, switch off, or what exactly we need to do depending on one of those devices. Okay, make sure here we're going to be careful about the end if and when we need to finish our loop as well. Okay, you will need to change the word device. What I mean here, we have some words like while the value preset, if the device is off, then send signal to the device. All those words, we're going to change them with the related device, whether it is temperature or moisture device or a light controlling device. Okay, you will need to change the word device to the name of the device being used. You will need to change the value as well. So we have here some values inputting, right? We need to change it as well to the physical variable, whatever is related. If it is temperature, what we're going to be controlling, what value it will be, and so on. Okay, that's the first thing. So the value will be measured. Another part of the question says draw. Whenever we're going to refine it from chapter 3 for each of those devices, we're going together after that to draw a flowchart for each of those algorithms, so that each is a subroutine. So it will be like a subroutine connected in one flowchart with an appropriate name. Okay, you can assume the system is still switched on and it is running and we're using it. Okay, so let's go. Here I'm going to show you from chapter 3, those were the algorithms provided in chapter 3. Okay, so this is related with the temperature algorithm. It states while system switch on, input the temperature. You will find this algorithm is very similar to this general one. Okay, so it looks like this. While the system is switched on, input the temperature. If the temperature is more, it means it's hot. So if it is more or larger than the preset value, then send signal. This is inside a glass house, okay, not a house. Send a signal to the window motor to open the window or leave it open in case it is open. Okay, another thing, they also want to send a signal to the actuator. This is to the window, this is to the actuator, to switch off the heater or leave it off. Okay, because the temperature is high, we need to open the window to cool it and switch off the heater. Otherwise, if it is else, means it is opposite. If it is less than, the temperature is cold. Okay, then we need to send a signal to the motor, to the window motor, to close the window because it is too cold. We need to maintain it a bit warm inside, and to the actuator to switch on the heater. Okay, this is very logical. You need to understand the basic, so you will be starting to work on those type of questions. This is related for the temperature device. Let's look at the moisture device. Exactly similar, but the logic is different here. So the system is switched on, input the moisture. If the moisture is less than the preset value, so the moisture is it is dry, so send signal to the actuator to open the sprinkler or the valve. Okay, sprinkler valve, or remain it or leave it open. else send it to the actuator. So it means it is quite dry, so open it. Otherwise, which is opposite, it's going to be quite high and humidity or the moisture is quite high, so we need to close the valve, okay, or remain it closed. We need to be careful about the end if and ending the loop. This is for the second device for the moisture. Third device, which is for the light. So for the light level, while the system is still switch on, input the light level value. If the light level is less than the preset value, we have here two preset values going to be. The first one is going to be for the daytime, okay. The second one, if it is less than also the night value, then we have two values. While the light, you want to set it for the morning or for the nighttime, which values you want to set. Nighttime, maybe it can be depending on the light intensity. Daytime, it's usually bright, so how you want it. Sometimes it can get cloudy as well, so it depends. So while both the light values are dim, you want it to be dim, then send signal to the actuator to switch off the light source, because you want it to be dim. You're setting both values to be less. So in this case, what will happen? The light will turn off because the light level should be low, specifically at the night time. Also the same for the daytime. Else, while at the night time, what do you want it to be? You want it to be more than the preset value. In this case, definitely you want to turn it on because you want it to be higher than the night value. So in this case, turn on the light because you want it to be high at the nighttime. So for the last one, send signal to the actuator to turn off the light, so it will be off because the day is daytime and the light is already too high. Okay, so those were from chapter 3, the algorithms. What we need to do right now, we need to refine those algorithms for the three of them, for all the three devices, and then we need to draw the charts. Okay, but while we're refining, let me first refine one by one. Okay, so while refining, we need to care that to change the word of device to that specific device, and we need to check whether it is off or on and what will happen while it is on and off, and we need to give extra statements whenever there is like phrases like leave on or leave off. Okay, this on the left side, this one is the one that I just show it to you in chapter 3 after refining. So let's go through it. In the first one, you will notice that we're just using same while switch on, and then we need to input the temperature, and if the temperature is more than the preset value, then we will have two options. Here simply we just put the two options like that, one after another. Send the signal to the motor to open the window or leave it open, send signal to the actuator to switch it on or leave it off, and so on. We just don't want it to do it like that. We want to be more specific. So in the first option, which is over here, we will have two, one about the window motor, one about the actuator. So if window is closed, then you can see here, this is indented, send signal to the window to open the window. Okay, end it and then go for the next if. If the heater is on, then send signal to the actuator to switch it off, because here it is, the temperature is high, we need to cool down. Okay, second one, we don't want to set it as just paragraph or sentence, and then if the window is open, it's going to be opposite of the first one, then send it to close the window, end it, and then if heater is off, then switch it on and end your if. We still need to end the if for the first one, and we need to end the loop because this is going to be continuous as long as the system is switch on. Okay, okay, that's the first refining for the first one. The second one is going to be about the moisture. Moisture one was really an easy one. So while the system is on, the moisture, we need to input it. So if it is less than the preset value, means it's going to be dry, then open the valve or let it be open. Otherwise, close it, okay, in case it is high humidity or high moisture. So we're just going to modify it by putting those if inside this if. So if the sprinkler valve is closed, then send the signal to open it. Otherwise, if it is valve is open, then send it to close it. That's it. It's very simple and clear. There is nothing to make sure that it is remain open or remain closed, because it's already clear and it is going to be looping. So that's the algorithm for the light system. For the light system, as I explained it, the preset value 1 is for the daytime, preset value 2 is for the nighttime. So we're just going to make it much clearer. It's going to be here, this part that we're going to create it over here. If the light source is off, then we're just going to make sure that to turn it on, the light. And then the next part, which is this one, if the light source is on, then make sure to turn off the light. And this is just a loop. It's going to continuously check. We don't need to make sure it is leave on or leave off or whatever. And then the last part, which is the else, and if the light source is on, then switch it off. So this is just a refining for the algorithm. Okay, let's draw right now the flow chart. This is for the temperature. So for the temperature, the flow chart will start first with the temperature. And remember, we're asked, let me go back to the question. Not that. We're to the question over here. They told us we changed it. Okay, in draw program flowchart for each algorithm so that it is like a subroutine. So that's why we're not we're going to think of it as it is a subroutine from a main system. We're just calling it. So let me get back again. So the flow chart will be as like this. So while the system is switched on, so we're going to start first. This is a temperature. Okay, that's the start. So input the temperature. So we're going to input the value, and wait, we're not inputting yet. We're going first to check if the system is on or off. That's the first one. It's a decision. Is it on or no? If it is no, then just stop the system. So the sensors will not be able to compare, not going to go in further process. So if it is yes, then we're going to go to the next step. Next step is input the temperature. That's a parallel rectangle that's going to ask you or process and input the value or output it for you. Whenever there's input or output, you're going to put it in this parallel rectangle. So as we input the temperature, then we're going to use the decision again. Whenever you have if, you better use the decision. So if the temperature is more than the preset value, then if it is yes, then we're going to use another decision, which is going to check the window. Is window closed? If it is yes, then the second line, which is going to process here, send the signal to open the window. Wait, and then this thing going to be keep repeating. Okay, if it is no, it's going to go for the next one. Next one, is the heater on? Okay, if it is no, it's going to be repeated the whole process from the beginning. If it is yes, then it's just simply going to send to the signal to the actuator to turn it off. Okay, so that's still related with the first part over here. Then let's go, that's the first part as I mentioned. Let's go to the else. This else will be coming from which one? From this decision. Where was this decision? Over here, we did it. So if it is no, means it's going to be opposite. We're just going to draw exactly the same here, but going to be opposite. So if it was window was closed here, it's going to be open here. Okay, so we're just going to simply repeat this here again. And finally, whatever is going to be off, it's going to be repeated from the beginning. That's the way the system will be running, and switch on, it will keep checking all the time. Okay, so if is the window open, yes, then send signal to the motor to close the window. Okay, is the heater off? If yes, then send it to turn on the heater. And if it is none of them is no, then it will go to the next step. And if there is no further step, it will just go back again to the beginning steps where the system is switch on. Okay, so that's related with that's the flow chart for the first one. Okay, so that's, as you can see, this is the then part and this is the else part. Okay, for the next one, which is the moisture, this one is the easiest always. Okay, for the moisture, if the moisture, so let's start here, moisture, we're starting with the name, starting the system is on or off, input the moisture, we're inputting it here, and if, again for the decision, if the moisture is less than the preset value, then that means it is quite dry. Then is the sprinkler valve closed? Then send signal to turn it on. You can put yes and no things, it's up to you, but it's better to put it. Okay, so is the sprinkler, so if it is yes, is yes. If it is no over here, then send it, otherwise it will go back from the beginning, because there is now another option down here to go down. Okay, if the moisture value is open, so if if the moisture is higher than the preset value, then is the sprinkler open? If it is yes, then send signal to close it, otherwise if it is no, it should be here, no, then send it back again to check it. So and so on, the system will keep repeating and checking how's the values and compare it to the preset values. Let's go for the next one. So that's then, and that's else value. Okay, so for the next one, for the light, so the light, this is the name for starting with a start, is the system is switch on. If it is no, then it's going to stop. If it is yes, then it's going to check the input light level. Okay, and it's going to compare it. If it is higher than the preset value 1, oh sorry, 2, we started first with the preset value 2 over here, then it's going to be, that's the first part. Okay, that's the second else part. So that's the first part. Okay, so if it is yes, then it's going to again check it for the preset value 1. If it is yes, it's going to check the light is off or no, and if it is off, yes, it's going to turn it on. Okay, switch it on, just exactly like here. And if it is no, it's going to be repeated. Okay, and if it is no over here for the preset value, it's going to go to check the next source. Okay, for the next light source is on or no. So over here it's going to go jump directly to the next one. We always said if there is another option, it will go to that option. If there is no another option like here, it just will go to the up one. Okay, let's go to the next option, which is else. If the light is on, okay, then send signal to switch off the light, otherwise no, it will go to the beginning of the system to check it is switch on or off, and so on. It will keep running. So that's for we're finding for the ending. Okay, for the same activity 4b, question number 2, draw a simple program flowchart which would check if the system was on and would then call 3 subroutines. So that's about calling 3 functions or subroutines. So we're going to start with start, and then we're going to check the system is on or off, or on or not, because they mention it here to check if the system is on or not. If it's no, then it will stop, otherwise it will call the 3 subroutines. That's one of the simplest questions. The first one, which is that temperature that we named it previously, so call temperature, call moisture, and call light. As the name you named it in the previous one, we didn't start with start in the previous ones. We started with the name of the subroutine, with temperature, with moisture, with light. So you need to put those exactly the same names, and that's it. As it is done, it will just recall them again and again whenever needed. For question number 3, here is a program flowchart to output the sum of 8 numbers. So you need to get a sum of 8 numbers. There are some errors here, so identify the errors in it and suggest improvements. The yes and no flow lines are positioned correctly, so nothing to worry about. Yes and no, they're correct. We just need to find out where is here. So it start, the count is set to 0. So if the count is more than 8, if it is not more than 8, it will stop, and if it is yes more than 8, it will input a number. Okay, and then it's going to count increase each time by 1, because it was set to 0, and then it will increase. What we're doing here, we're summing. Okay, you can feel something is strange here. Sum that number and add it to the sum. So we're forgetting some of the points over here. So let's try to correct those points. So you will find, first of all, what I told you strange here is the sum initiation. Okay, as we initiated count, which is defined to equal to 0, we need as well to initiate the sum, make it equal to 0, otherwise it will be undefined here. Okay, Another problem is the count. It should not be more than 8. It just should be under 8 or below 8 because we're counting up to 8 numbers. So it should be less than 8. That's the second error. And the last part that needs correction, which is, can it come to your mind, which is the output, the print out. They need to print those 8 numbers. So you need to print the sum at the end whenever it is not anymore less than 8, it is becoming 8 or more than 8, those numbers. So just before stopping, print it out and stop the loop. So you can see that those are all the 3 things. So that's the end of this activity 4B. I will be doing right now the exam style question, so you can come in the next videos to answer the exam style questions with me.